there is, I think, evolution in general goes the way that we try to make the devices as small as possible. So in general, what we're using these days in the optical systems, this is a century-long back technology. This is how the regular lenses, this is how they focus the light. You need to have a certain curvature. And if you would like to change the focal spot position, you either need to repolish it, change the curvature of the lens, or add some other lenses and change mechanically the distance between them. But in case of meta surfaces, everything happens on this interface. So depending on the microstructure, on the shape, on their positions, and you can have similar functionality. We particularly pursue the direction of reconfigurable metasurfaces because this is quite unique for the field. It's as I said, it's a holy grail for optical engineers to have reconfigurable optical systems. So recently in our group, we found out a new material type, which is called chalcogenide glasses or phase change materials. One of them from that family is a well-known one. This is the GST materials, which is used in Blu-rays and CDs and DVDs. But that material, so we adapted this kind of family of the materials and extended it towards the optical properties. So we tried to reduce its absorption losses. In one state, this material it's amorphous. In another state, we bring this material to it forms a crystal lattice. So it's a very structured and formed material. And then there are also some states in between. How do we transition this material from one state to the other one? I think more interesting is the approach of heating it locally by electrical pulses. This will be on-chip controlled lens, a zoom lens in this case. So that is our nearest term goal. And of course, we would like to increase its efficiency, increase its bandwidth. So then it could be integrated into night vision devices, or potentially we could consider other types of materials. So it could be also used for visible in cameras, cell phone cameras. This is more like an optical engine, which hopefully the next researchers will pick it up and see how they can apply it. What we envision is a fully reconfigurable optical system.